Hello, everyone. Welcome to the Nathan channel. I'm your host, Nathan. And if you are new, welcome. If you are not new, welcome back. Today, we're going to be talking about something really interesting, one of my special interests, which is black holes and different things relating to its structure and what it interacts with. So without further ado, here we go. Black holes are incredibly fascinating and mysterious objects in the universe. Here are some interesting facts about them. Gravitational pull. Black holes have an immensely strong gravitational pull due to their compact and dense nature. What has been said is that they are infinitely dense. This gravitational force is so intense that nothing, not even light, can escape from it, leading to their name, black hole. Formation. Black holes can be formed through various processes. The most common types are stellar black holes, which result from the gravitational collapse of massive stars. Supermassive black holes are found at the center of galaxies and are thought to form through a combination of accretion and mergers of smaller black holes. So, a really interesting way that black holes form is after the death of a star, the weight of the star collapses in on itself and it can turn into a black hole. It's actually really interesting. Depends on the size of the star and the type of death, but you know what it does towards the end of its life cycle. But typically, so with stars, the bigger the star, the shorter the lifespan because it's using up so much energy. The smaller the star, the longer the span of life because it doesn't use up that much energy throughout its lifespan. And then medium stars like our sun have an average lifespan. And a lot of times when these stars die, depending on their size and their formation, they will turn into things like supernovas, nebulas, supernovas or black holes. So it's really interesting to look at images of that or artist impressions of what that looks like or telescope imagery. Event horizon. The boundary surrounding a black hole called the event horizon is the point of no return. Once an object crosses the event horizon, it is trapped within its gravitational pull and cannot escape. So if you think about a black hole as an eyeball or as a flat image of an eye, the event horizon can be sort of where the iris is, the colored part of the eye. Time dilation. According to Einstein's theory of relativity, time near a black hole runs slower than it does in space further away from it. This phenomenon is called time dilation and is a consequence of intense gravitational field. Okay, so this is a really interesting topic of discussion in my opinion because I used to think of time as something independent of everything else. Time will always run no matter what happens, right? And it will always run at the same rate. At least that's what I thought. And it is something that is not physical. It is just something that exists, that doesn't touch anything, is non-tangible, and is just part of existence. But it seems to be actually quite physically embedded in the fabric of space-time, which was a really insane discovery that I had back in high school. If you bend the fabric of space, or it's actually called the fabric of space-time, it will impact time. And it can, if you stretch it out really strongly, time will run really slow. Now, that doesn't happen in the opposite. If it's like fabric, you can't make it contract and change it. You can bend it, but you can't like an accordion pulling it back and making it contract within itself and make time go faster. You can't do that, to my understanding, but you can slow it down, which is fascinating because it means that time is a lot more physical than we think it is. Size and mass. Black holes come in various sizes, with stellar black holes having masses a few times that of our sun, while supermassive black holes can be millions or even billions of times more massive than the sun. Now, something really interesting is that, we typically think of black holes as huge, ginormous, and they are. But there are microscopic black holes that have formed, I believe, in the Large Hadron Collider at CERN, the Center for European Nuclear Research in Geneva, Switzerland, where the particle accelerator is at. That experiment, that institution of research, I have heard that there are microscopic black holes. They have a very short lifespan. They will evaporate and go away very fast, but they have observed this. Hawking radiation. Theoretical physicist Stephen Hawking proposed that black holes can emit a form of radiation now known as Hawking radiation. This radiation is due to quantum effects near the event horizon and suggests that black holes can slowly lose mass over time. The information paradox. Black holes are at the center of a long-standing debate known as the black hole information paradox. This question concerns the fate of information that falls into a black hole. It challenges some of our fundamental principles in physics, including the conservation of information. So this is really interesting. We have black holes, and think about the particles that are right at the edge of a black hole, right at the boundary line between the event horizon and the outside of that point of no return, whether you get pulled in or not. Apparently, I've heard hypotheses that particles at this stage of being pulled in or not can go in and out of existence. Now, that's related to the Higgs field and other things too. But I think it's really interesting because the information paradox, to me at least, in my point of view, I think it's just trying to understand what happens to the information and to the things that go into a black hole. Where does it go? If it's a fully structured wormhole where you have the initial black hole, what does that do? Where does it take what it consumes, right? And we don't have the answers to these questions yet. Wormholes. There's a theoretical speculation that black holes might be connected to other regions of spacetime through what are called wormholes. Wormholes are hypothetical shortcuts in the fabric of spacetime, potentially allowing for faster than light travel. So these are really actually kind of the concept of a portal. You have things that go in black holes, get absorbed, get pulled in by the super strong strength of gravity, of the gravitational forces, and you don't know where it goes, but I should say this, I should have started with this. Wormholes are a structure more than just a black hole. Black hole is just a part of it. So it starts with a black hole and it's like a funnel, and then there's another funnel that spits out the matter that went in a different region of the universe. And those are the spitting out portion of that structure is a much more hypothetical structure than black holes. They're called white holes. You can look them up. And I think they're very interesting as well. But that's kind of the concept of a wormhole and what they do. Hypothetically speaking, because we haven't sent anyone out there yet to know. But the no-hair theorem. The no-hair theorem in black hole physics suggests that black holes are described by just three properties: mass, electric charge, and angular momentum, or spin. All other details about objects that form the black hole are lost. Supermassive black holes. Supermassive black holes found at the centers of galaxies play a significant role in galactic dynamics. They are thought to influence the motion of stars and the growth of galaxies. That must be, I think that's very true, because black holes are so massive, some of them, that even though the universe is infinitely expanding, they are so large that the size of galaxies, they must play a role in the motion dynamics of the universe as a whole, and they must play a role in the tugging of matter towards one direction or another, or how it curves, or how it spins, or how it rotates. I definitely think that. Black holes remain a subject of intense scientific study, and they continue to challenge our understanding of the laws of physics and the nature of the universe. They are some of the most enigmatic and intriguing objects in the cosmos. If you guys like that video and you found these types of topics to be interesting, I find them to be fascinating. I could talk about them all day. Let me know in the comments down below, and I will gladly make a series of these videos. So again, if you enjoyed, please like, comment, share, and subscribe, and I will see you in the next video.